Assalamu alaikum and hello everyone. Welcome back to EduZone. In this video, we are diving into an interesting and fun topic in mathematics fractions. Fractions are something we deal with every day, even if we don't realize it. Think about it, we share a pizza, divide a chocolate bar, or split fruits with friends and family. This simple act of sharing, cutting, dividing, or even adding and subtracting parts is what we call fractions in mathematics. Fractions are everywhere in our daily lives. Whether you are slicing a cake, eating half of an apple, or dividing a pie, these actions show how we work with fractions in real life. And in maths, fractions are used to represent these divided parts. Let me show you some examples to help you visualize this. Here's a pizza in the first image. It's cut into 8 equal parts. These parts together are called eighths. Eighths. Okay. Here, the whole pizza is divided into 8 equal parts, and the whole parts, total number of parts, are called as eighths. Okay. The pizza is cut into eighths. In the second example, you can see a pie cut into 4 equal parts 1, 2, 3, 4. Yes, here these parts are called fourths. This is also called as quarters. Quarters. We are talking about whole parts, not a single. Now, what is the pie cut up into here? In this image, you can see the pie is cut into sixths. Six parts called sixths. Yes. So far, we have learned what the total divided parts are called. Now let's go a step further and understand what fractions are and how they represent these divided parts. In this video, we are going to cover everything about fractions, including what is a fraction, what are the types of fractions, like proper, improper, like, unlike, mixed, and equivalent fractions. And we are dealing with addition of fractions, subtracting fractions, multiplying fractions, and dividing fractions. Okay, are you ready? Let's get started and make fractions fun and easy to understand. We already discussed about the division of a whole into parts. Let's go further and focus on the single part and their names. Here you can see a whole square and it's cut into two equal parts. When something is divided into two equal pieces, each part is called a half. Okay, each piece is one half of the whole. Yes, if you divide a square into four equal parts, each part is called one fourth or a quarter, and collectively they are referred to as fourths. Four equal parts of a circle are called fourths or quarters. Each part is one fourth of the whole. Yes, now we move on to what fractions represent and how to write fractions. What is a fraction? A fraction represents a part of a whole. It shows one or more equal parts of something divided into portions. Here is an apple and you can see here is an whole apple. So if we divide this apple into two equal parts, then each part is called a half or 1 out of 2. Total number of parts? Two halves, right? Two halves, that is two parts, but each part is called as half. Okay, to write this as a fraction, we are using two elements, the numerator and the denominator. The numerator is the top number, shows how many parts you are considering, that is how many parts you are having, you want to have. And the denominator is the bottom number, shows the total number of parts the apple is divided into. If you take one part, if you consider one part, then the fraction is 1 bar 2, as you can see here. Yes, in the next example, you can see here a boy has two cookies and shares one cookie with his friend. So the fraction of cookies shared is numerator equal to 1, that is the number of cookies shared, and denominator equal to 2, that is total cookies the boy has. So the fraction is 1 bar 2. Now let's learn to write fractions from area models. As you can see here, there is a circle. Okay. Area models show fractions as parts of a whole. So here in this circle, circle is divided into six equal parts where two parts are shaded. So to write the fraction of the shaded part, we have to consider numerator, then the fraction bar and denominator. Okay. So at the numerator place, we have to write the shaded part, that is equal to 2. Here the shaded parts are 2. Then at the denominator place, we have to write the total number of parts this circle is divided into. So here the denominator is 6. And there is a fraction bar right in between this 2 and 6. So this fraction bar is also called as win column in mathematics. In general, we call fraction bar. So the numerator is the top number, denominator is the bottom number, and the fraction bar is the win column. Let's revise quickly how to write fractions. Step 1, numerator, that is count how many parts you are looking at. Then denominator, discounts the total number of parts in the whole, and write the fraction with the numerator on top and then a fraction bar, that is win column, and then at the bottom place you have to write the denominator. Okay, here is an example. If there are 3 red balls out of 6 balls in total, then write down the fraction of red balls. So numerator is equal to red balls, that is 3, and denominator equal to total balls, which is equal to 6. So the fraction is 3 bar 6. Let's move on to the next example. A rectangle cut into 8 equal squares. If 3 of these squares are shaded, the fraction of the shaded part is. Now we have to write the fraction for the shaded parts. So to write the fraction, first we have to consider the numerator, which is equal to 3 shaded squares, right? And then denominator, which is equal to 8. Here 8 are the total squares a rectangle is cut into. So the fraction is 3 bar 8. Now let's try some word problem examples. Question number 1. Write the fraction of even numbers between 1 and 10. Step number 1. List the numbers from 1 to 10. Okay. Then step number 2. Find the even numbers. Even numbers are divisible by 2. They are 2, 4, 6, 8 and 10. Step number 3. Count the even numbers. So you can see here the even number countings are 5. So write the fraction. To write down the fraction, we have to consider numerator and denominator. So numerator is equal to 5. These are the countings of even numbers, and denominator equal to 10. These are the total countings of the numbers. Matlab 1 to 10, there are 10 countings. So the fraction is 5 bar 10. Okay, here in this example, you can see an aquarium, and in this aquarium, there are 10 fishes. Okay, so the total number of fishes are 10. So the denominator equal to 10 because total number equal to denominator. So the total number of fishes are 10, which is equal to denominator. And 3 of them are goldfish. As you can see here, 3 are goldfish. Then what fraction of the fish are not goldfish? Now we have to write the fraction for which are not goldfish. So out of this 10, 3 are goldfish. So what we have to do? We have to subtract 3 from 10. Then we will get 7. Okay. So the numerator is equal to 7. So the fraction of fish that are not goldfish are 7 bar 10. Here in this example, you can see watermelon parts. So, the question is there are 5 pieces of watermelon and 2 pieces are left. What fraction of the watermelon is left? Now we have to write down the fraction for leftover pieces. Yes, as you can see, there are 2 pieces left, right? So, the leftover pieces are equal to 2, which is equal to numerator. And the total number of pieces are 5, which must be written in the denominator place. So the fraction is 2 bar 5. It's very simple. Yes, so far we have studied how to write fractions and we have done with this. Now let's move on to the next topic, that is the types of fraction. Proper, improper, and mixed fractions, like and unlike fractions, and equivalent fractions. These are the types of fractions. So let's start with proper fraction. A proper fraction is a fraction where the numerator, that is the top number, is less than the denominator, the bottom number. So these fractions are always less than 1. As you can see here in the example, 3 bar 5 and 2 bar 7, where 3 is less than 5 and 2 is less than 7. Okay, the next one is improper fraction. An improper fraction is a fraction where the numerator is greater than or equal to the denominator. Matlab here the numerator must be greater than or equal to the denominator. These fractions are equal to or greater than 1. So here 7 bar 4 and 9 bar 3 are the examples. Here you can see 7 is greater than 4 and 9 is equal to 3. How it is equal to 3? It's equal because you can see here 9 is divisible by 3. Now let's move on to the next one, that is mixed fraction here. Okay, in the mixed fraction you can see here mixed fractions are a combination of a whole number and a fraction. Okay, it's a combination of a whole number and a fraction. It represents a number greater than 1. For example, 1, 2 out of 3, 1, 2 bar 3, 2, 1 bar 4, 3, 3 bar 5. This shows a whole number and a fraction together. You can see here 1, 2 bar 3 matlab 1 is the whole one and 2 bar 3 is the 2 bar 3 of the next one. Okay, here 2 1 bar 4, that is two whole number whole, and the third one, it is only one, we consider only one out of this third one. Okay, so 3 3 bar 5, out of this 4 we want only 3 bar 5. Yes. Yes, next now we'll see what are the like fractions and unlike fractions. Okay, here in the like fractions are fractions that have the same denominator. This means the total number of parts in both fractions is the same. Here we have to consider two fractions or two or more fractions. Okay, we have to consider two or more fractions and we have to compare them whether they are like or unlike. Okay, here in this example you can see 2 bar 7 and 5 bar 7, okay, are like fractions because both have 7 as a denominator. Here two different figures, two different images, but both have 7 denominators. Okay, next one, unlike fractions. Yeah, unlike fractions are fractions that have different denominators. This means that the total number of parts in each fraction is different. Here also we have to consider, we have to compare two or more fractions to check whether they are like or unlike. Okay, here 1 bar 4, 3 bar 7, 2 bar 5. Okay, all these fractions have different denominators, 4, 7 and 5. So they are unlike fractions. Okay, now we'll move on to equivalent fractions. This is the last type of fraction we are studying under the types of fractions. Okay, so what are equivalent fractions here? Equivalent fractions are fractions that may look different but actually represent the same value or the same portion of a whole. Okay, for example, these fractions have different numerators and denominators, but their value is the same. Let's understand with a simple example. Imagine you can see here two pies. Okay, these are, you will consider these two are the pies. The first pie is divided into three equal parts. If you take 1 out of 3, the fraction is 1 bar 3. And the second pie is divided into 6 equal parts. If you take 2 parts out of 6, the fraction is 2 bar 6. Although the fraction looks different, both represent the same portion of the pie. That's why they are called equivalent fractions. Okay, the size is same, but they looks different, but the size is same. Here we are considering 1 out of this 3. Here we are considering 2. This 2 is equal to the 1, 2 out of 6. Here 2 is equal to the 1 of the other one. So they are called as equivalent fractions. As we studied through this example, that the equivalent fractions are fractions that may look different but represent the same value. Yes, these fractions have the same overall proportion even though the numerator and denominator are different. Now let's see how to identify equivalent fractions. Multiply or divide both the numerator and the denominator of a fraction by the same number. If you multiply by the same number or divide by the same number, then we will get the equivalent fractions. Finding equivalent fraction, we either multiply or divide both the numerator and denominator by the same number. As you can see here in the example, 1 bar 3, it is multiplied with 2. Both the numerator and denominator is multiplied with 2 to get 2 bar 6. So here 1 bar 3 and 2 bar 6 are equivalent fractions. Here are some more examples. Let's go through these examples. So example number 1 is using multiplication. So we have to find out the equivalent fraction of 3 bar 4. First we'll multiply this by 2, both the numerator and denominator by 2, then we'll get 6 by 8. We can also find another equivalent fraction by multiplying it by 3. So 3, that is 9 by 12. So the equivalent fractions will be 3 by 4, 6 by 8 and 9 by 12 and so on. You can get still more equivalent fractions. In the next example, you can see here we have to find out the equivalent fraction of 8 by 12 by using a division method. So we'll divide both the numerator and denominator by 4 and we'll get 2 by 3, a equivalent fraction which is equivalent to 8 by 12. In this example, you can see 3 by 5 is equivalent to 6 by 10 and 12 by 20. How it is? If we multiply both, that is 3 by 5 by 2, we get 6 by 10 which is equivalent to 3 by 5, right? Again, if we multiply both 3 and 5 by 4 to get 12 by 20 which is also equivalent. So 3 by 5 is equivalent to 6 by 10 and 12 by 20. Here we have done with all the types of fractions and now let's start with the new topic, that is adding and subtracting fractions. Are you ready? Let's get started. Addition in mathematics is the process of combining two or more numbers to find their total or sum. It is one of the basic operations in arithmetic, right? Yes. So here, addition in fractions, adding fractions depends on whether the denominators, that is the bottom numbers, are the same or different. When denominators are the same, that is like fractions, add the numerators and keep the denominator the same. If denominators are different, unlike fractions, find a common denominator, usually the least common multiple, then adjust the fractions and add them. Here is an example. Let's start. As you can see here in this example, 3 bar 8 and 2 bar 8, these are like fractions. So while adding the like fractions, we have to keep denominator as it is, and then we have to add only the numerator. So here we add 3 and 2 to get 5. Okay. The sum of 3 plus 2 is 5. So the fraction is 5 bar 8. Okay. So adding 3 by 8 and 2 by 8 together equals 5 by 8. Yes, the addition of fractions can also be done by decomposition methods. As you can see here, we can decompose 3 bar 8 and 2 bar 8 into 1 eighths. Okay. As you can see here in image 1 here, this rectangle is divided into 8 equal parts where each part is 1 eighth. So 1 by 8 plus 1 by 8 plus 1 by 8. And in the image 2 also you can see here 2 bar 8 here also we can write as 1 by 8 1 by 8, right? As the denominator is same, then we can add only the numerators here 1 plus 1 plus 1 plus 1 plus 1, which is equal to 5 bar 8, which is the, but actually we prefer writing the previous one. Okay, this is only for the explanation. Yes. Now here, when adding fractions with common denominators, we add the numerators as we studied. Here 1 bar 8 plus 4 bar 8, which is equal to 5 by 8, right? It's 5 bar 8. So we have to check whether this is in the simplest form or not. Means whether it is further divisible or not. If it is not, then this itself is the simplest form. If it is divisible, then we have to divide this and we have to get its simplest form. As we can see here, if our answer is not in simplest form, we must simplify it. Here 1 bar 8 plus 3 bar 8, which is equal to 4 bar 8, that is 4 bar 8. It is divisible further, right? Because both 4 and 8 goes in the table 4. It can be divisible by 4. So we can make this simplest. We can further simplify this, right? So by dividing both the numerator and denominator by 4, we can further simplify this. What we have to do here, we have to divide 4 and 8 with 4 to get the result, which is 1 by 2. That is 1 bar 2. Okay, this is the simplest of the fraction. Yes. 1 by 8 plus 3 by 4, which is equal to 4 by 8, but we have to simplify this to get the final result. The final result will be 1 by 2. This is in the simplest form. Yes, now we know how to add the fractions if the fractions are like terms. Okay, if they are like, then we can add them easily by adding only the numerator and keeping the denominator as it is. Okay, if the denominators are common, if the fraction is like fraction, if, okay, if here the fraction is not like, that is if the fraction is unlike, then first we have to create equivalent fractions. We can create equivalent fractions by finding the lowest common denominator, LCD, of our denominators. Then we can do the addition, as you can see here further. Okay, as you can see here in this example, 1 bar 3 and 1 bar 4, where the denominators are unlike, right? These are unlike fractions. So we have to get the lowest common denominator, LCD, for 3 and 4, which is 12. Okay. Now we have to find the equivalent fraction. We have to check the denominators of both the fractions, like with which number it is multiplied to get 12. Okay, here 3 is multiplied with 4 to get 12, so we have to multiply both the numerator and denominator with 4, and the result will be 4 by 12. Yes, similarly here 1 bar 4, we have to check the denominator 4 with which number we have to multiply with to get 12. Here we have to multiply 4 with 3 to get 12. So we have to multiply both the numerator and denominator to get the result. Now we can easily add 4 bar 12 with 3 bar 12. How? Because these are the like fractions now. We can add the numerator and we can keep the denominator as it is. That is 4 plus 3, which is equal to 7, and the denominator is 12. Okay, here the denominator is common now, so we can write as it is 7 bar 12. Now we can see whether it is simplified further. If it is not further simplified, then we can stop here. Okay, 7 by 12, whether it can be simplified further. If no, then we'll stop here. Okay, 7 by 12 is the answer. Yes. In this way, we have to add the unlike fractions. Now let's do subtraction. As we have studied in the addition part, okay, if the fractions are like, then we have to add the numerator and we have to keep the denominator as it is. And if they are unlike, then we have to get the least common denominator, and then we have to get the equivalent fraction, and then we can add, right? Similarly, here also we have to do the same thing. If the fractions are like, then we can subtract the numerator and we can keep the denominator as it is. If they are unlike, here we have to get the least common denominator, and then we can get the equivalent fraction, and then we can subtract. Okay, similar to that, but here it is subtraction. So here in this first example, you can see here, let us visualize subtracting fractions using area models. As you can see here, there are two rectangles, and these rectangles are equally divided into 8 equal parts. Okay, and in the first rectangle, 7 parts are shaded, and in the second rectangle, 4 parts are shaded. So we want to remove now 4 from 7. Okay, 4 bar 8 must be subtracted from 7 bar 8. Okay, so what we have to do? We have to remove 4 shaded boxes from rectangle 1. Okay, we cross it out with an X mark here as it is shown. And what is the remaining here? The remaining is 3. Okay, so the result is 3 bar 8. We have to keep denominator as it is because this is a like fraction. Okay, if the denominators are common, then these are the like fractions. Here in the like fractions, we must not take any this one like least common denominators. Okay, we have to directly subtract 4 from 7. Okay, yes. Now let us consider examples, some more examples, but without using area models. You can see here there are two questions. One is addition and one is subtraction. We'll solve both of this. Okay, in addition, we know that 2 plus 6, that is 8 bar 9, because we have to only add the numerator, and denominator we have to keep as it is. In the subtraction also we have to do the same thing. 7 minus 5, that is 2, and we have to keep the denominator as it is. And here we can check for the simplest form. Here the first question is 8 bar 9, so there is no any simplest form here. In the second question, it can be divided by 2 here, so divide by 2. 2 ones are 2, 6 are 12, 1 bar 6, that is the final. Okay, if we just simplify this, otherwise we can keep as it is. If you want to simplify, we can simplify this. Okay, then we'll get the answer 1 bar 6. Yes, here in this example, you can see here 5 bar 7 minus 2 bar 7, which is equal to 3 bar 7, because here these fractions have common denominators, and so we subtract only the numerators. Okay, so the result is 3 bar 7. Numerator we have to subtract, and denominator we have to keep as it is because here denominators are common. But yes, as you can see here in this example, the denominators are not common, so these are unlike fractions. For unlike fractions, we have to check the lowest common denominator. Okay, we have to remove the lowest common denominator for 6 and 5, which is 30. Okay, so what we have to do, we have to check the denominators now. Now you have to adjust the fractions to have the same denominator. How will adjust this? Divide the LCD by each denominator to find the factor needed to make the denominator equal. Okay, then you have to multiply both the numerator and the denominator of each fraction by this factor. Okay, here you can see 5 is the factor, and we are multiplying 6 with 5 to get 30 and 5 with 5 to get 25. So the fraction is 25 by 30. And in the next one, here you can see 1 bar 5. So we have to multiply 5 with 6. So if we multiply 5 denominator with 6, then we have to multiply with the same number, the numerator also. Here the second fraction is 6 bar 30. Now what we have to do, once the denominators are the same, subtract the numerators and keep the denominator unchanged. Okay, then check for the result whether it can be simplified or not. Okay, if yes, then you have to simplify it. If not, then you have to keep as it is. Okay, yes. Here what you have to remember, when the denominators are the same, we add or subtract the numerators only. Okay, and if the denominators are not the same, we can use equivalent fractions. Yes. Now let's move on to the final topic of this chapter, multiplying and dividing fractions. But before we dive in, I have a small request. If you find this video helpful, please don't forget to like, share and subscribe to my channel. Your support means a lot and helps me create more such videos for you. Also, let me know in the comments if this video was helpful or if there are other topics you would like me to cover. I truly value your feedback and it inspires me to keep improving and creating content just for you. Thank you. Okay, let's first understand multiplication and division in mathematics and we'll apply these concepts to fractions. Okay, what is multiplication? Multiplication is a mathematical operation where you add a number to itself repeatedly for a specified number of times. It's a shortcut for repeated addition. Okay, yes. Yes, when 3 is multiplied with 4 means adding 3 4 times. Here 3 plus 3 plus 3 plus 3 which is equal to 12. Here 3 is the multiplicand, 4 is the multiplier and 12 is the product. Here what we do is we multiply. 3 is the multiplicand and 4 is the multiplier. And the result is we have to multiply 3 with 4 to get the result that is 12. That is the product. Okay. So what is the division here? Division is the process of splitting a number into equal parts or groups. It tells us how many times one number, that is the divisor, can fit into another number, the dividend. So for example, 12 divided by 4 means splitting 12 into 4 equal parts. Each part is 3. Here 12 is the dividend, 4 is the divider and 3 is the quotient. Okay. Yes, now let us see how does this relate to fractions. Multiplication of fractions. Let's start with multiplications of fractions. To multiply fractions, multiply the numerators, top numbers together and the denominators, bottom numbers together. Okay, then we'll get the result. As you can see here in the example, 2 bar 3 and 4 bar 5 is multiplied together to get 8 bar 15. Here we multiplied the numerators together and the denominators together. Then the result is 8 bar 15. Now we are going to further study multiplying fractions by fractions through area models and word problems. Now first we'll see word problem here. 3/4 of a plate of gelatin was left after a party. Kian had half of what was left. Okay, how much gelatin did Kian eat? How to multiply? As we have studied earlier, we have to multiply both the numerator and denominator separately and we have tried to go down the answer. 3 into 1 which is equal to 3 and 4 into 2 which is equal to 8. So the result is 3 bar 8. We have directly multiplied 3 into 1 and 4 into 2 to get the answer, right? Yes, so the result is 3 bar 8. Now, the same question we will solve with area models. Okay. Here, we consider rectangle as our area model and in the first step, divide the rectangle by 4 because the denominator here is 4, right? Matlab this rectangle is divided into 4 equal parts and at the numerator place we can see 3 here. So, we have to shade 3 out of 4. Then we have to write 3 bar 4, right? Yes. Now we have to draw a horizontal line which passes exactly in between this rectangle. Now divide the rectangle by 2. Then shade 1 bar 2. Now we have to shade 1 bar 2. As you can see here there are two parts. Here we have to shade one out of these two parts. Okay. Yes, you can see here at the last. So now the final result will be number of overlapping sections. Overlapping sections, how many numbers are overlapped here? 1, 2, 3. 3 numbers are overlapped and the total numbers are 8. So what we have to write? 3 in the numerator place and 8 at the denominator place. Yes, in this way we can solve multiplication of fractions using area models. Now we will see how to multiply fractions and mixed fractions. So here there is a question. What if 2 1 bar 4 of gelatin was left? What is 1 by 2 of it? Matlab 2 1 by 4 of the gelatin is left and we want half of that. Okay, half of that. So what we have to do? We have to convert this mixed fraction into proper fraction. How we can do this? As you can see here, 2 1 by 4 that is 2 quarter is in mixed fraction, right? So we have to convert this mix to proper first. How we can do this? We have to multiply the denominator of the fraction part that is 1 by 4 with the whole number, that is 2. So 4 multiplied with 2 we will get 8, and then we have to add with the numerator of the fraction 1 bar 4. Then the answer will be 8 plus 1 9, and then 9 bar 4 we have to keep the denominator again as it is. So we will get 9 bar 4 is a fraction. Now we have to multiply this with 1 bar 2. Okay, the answer will get 9 bar 8. We can further like simplify if needed. We can simplify the final answer if needed. Here we can either convert this to the mixed fraction or we can keep as it is. Okay, if we want to convert this 9 bar 8 into mixed fraction, then we have to follow some steps here. Okay, number 1, divide the numerator by the denominator. So here the numerator is divided by the denominator and we'll get 1 as the remainder. Okay, next, step number 2, write the quotient as the whole number part. The quotient 1 becomes the whole number. Yes. Then step number 3, write the remainder as the numerator. The remainder must be written as the numerator. The remainder 1 becomes the numerator of the fractional part. Now keep the denominator 8 as it is. Okay, the same. Then combine the whole number and fraction. That itself is a mixed fraction. Okay. Yes. Let's move on to the next example for better understanding. Okay. So here there is a question. A running trail covers 3 by 4 of a mile. If a runner is halfway through the trail, then what distance has he covered? We have to get half of 3 by 4. Let us solve this through area model. So the first step is start with 3 by 4. 3 by 4, we have to draw a rectangle which is divided into 4 equal parts because the denominator is 4. Shade 3 out of 4 parts to show 3 bar 4. Next step, we have to take half of the shaded part. Okay, you want half of what you shaded. Then divide the shaded 3 parts into 2 equal groups. Each group will have 1.5 parts, right? Then so half of 3 by 4 means you are taking 1.5 out of the total 4 parts. Now in the last step, divide each of the 4 big parts into 2 smaller parts, making 8 equal parts. Since 3 by 4 is equal to 6 out of 8, then half of that is 3 out of 8. That is the answer. This you can solve very easily through the multiplication of fraction just by multiplying the numerator as well as denominator. Numerator with numerator and denominator with denominator. Half is multiplied by 3 by 4. Then we'll get the result. Numerators we have to multiply 1 and 3, then we'll get 3, and denominators 2 and 4 multiplied and we'll get 8. So the answer is 3 by 8. Let's try this. Okay, a field is 3 by 4 meters wide and 2 by 3 meters long. So what is the total area? As you know, the formula for area is length into width, or we can say length into breadth. So here you have to just multiply length with width. Okay, 3 by 4 multiplied with 2 bar 3. Then the answer is 6 bar 12, which is further simplified. Say, we can divide this by 6 table. So 6 ones are 6, 6 twos are 12. 1 by 2 meter squares, because length is meter and breadth is also in meter. Meter into meter, that is meter square. Yes, we have done with all the basic topics what we have mentioned. But now let's wrap up this video with our final topic, that is how to divide fractions. Let's move on to the final topic of this video, dividing fractions. The first question, try this. 1 bar 2 divided by 1 bar 4. Here in the first step, you have to keep, switch and flip. It's very easy. First part you have to keep as it is. Okay, 1 bar 2 you have to keep as it is, which is divided by 1 bar 4. Here the second part is flipped. It is reciprocal. Matlab the denominator comes up and numerator comes down. Denominator comes to the numerator place and numerator comes to the denominator place. Then we have to multiply. 4 ones are 4, 2 ones are 2, 4 by 2. Then it is further divisible by 2. So the answer is 2 bar 1, that is, which is equal to 2. Okay, it's very easy. Okay, let's solve another example. 2 bar 5 divided by 2 bar 3. Now what we have to do? We have to keep the first part, that is 2 by 5 as it is, and the second part 2 by 3 we have to flip up. That is, we have to write the denominator in the numerator place and numerator in the denominator place. Now we have to multiply the numerator and then we have to multiply the denominator. Numerator 2 and 3 is multiplied and we'll get 6, and denominator 5 and 2 is multiplied and we'll get 10. So the answer is 6 bar 10. It is further simplified, so we can divide this by 2, both numerator and denominator. So the final answer is 3 bar 5. Now let's take the other example and see how it works. Try this. A cyclist completed a journey covering 4 bar 5 of a mile in 9 minutes. If he maintains the same pace each minute, what is the distance covered per minute? We have to divide 4 bar 5 by 9. So what we have to do? 9 matlab the denominator is always 1. If there is no denominator, then we have to keep denominator 1. 9 by 1. Okay, we know that all whole numbers have a denominator of 1. So, to get the reciprocal of a fraction, we have to switch the numerator and the denominator. We have to flip it. We have to switch it. Okay, so we will get 1 by 9. Now we can solve the division method. That is, we have to multiply numerator with numerator and denominator with denominator. 4 is multiplied with 1 and we'll get 4, and 5 with 9 and we'll get 45. 4 bar 45, and we have to check whether it can be further simplified. If no, then we'll stop here. So the cyclist covered 4 bar 45 of a mile per minute. That is the answer. It's too easy, right? Now let's solve another problem. Try this. Okay, a group of 4 athletes joined a relay race that is 7 bar 8 miles long. The marathon has 4 parts with equal distances where each of them will participate. How many miles will each of them cover? As you can see here, 4 athletes joined a relay race that is 7 bar 8 miles long. So we have to write 7 bar 8. The marathon has 4 parts with equal distance. So we have to divide this with 4. Then we can get the answer, like how many miles will each of them cover. We have to keep 7 by 8 as it is, and the divisor 4, what we have to do, we have to flip it. We have to switch the numerator to denominator and denominator to the numerator. As 4 is a whole number, then the denominator is 1. Now you have to multiply numerator with numerator and denominator with denominator, and you will get 7 bar 32. 7 ones are 7 and 8 fours are 32. 7 bar 32, and you have to check whether it can be further simplified. If no, then you have to keep as it is. And here, how many miles will each of them cover? Each athlete will cover 7 bar 32 of a mile. That is the answer. Thanks for watching. If you like this video, please don't forget to like, share and subscribe to my channel. Allah Hafiz. Fi Amanillah.